Hello, welcome to my channel. Let's continue the 2013 MIT Integration Bee. Today is the part 3 of this series of videos. We will work on problem 11 to problem 15. If you missed the part 1 and part 2, you can click here or click the link in the description box under this video. Let's see problem 11. We have this sine square multiply cosine square in this integral, and we try to simplify it first. So we use the double angle formula for sine function. So here sine 2x equals to 2 times sine x cosine x. Then we square them on both sides. So we got sine square cosine square equals to 1 over 4 multiplied sine 2x square. Next, we replace the sine square cosine square by the right hand side. So we got here. Now we need to deal with the sine square term inside this integral. We use the double angle formula again for the cosine function. So we replace this square term with 1 minus cosine 4x divided by 2. So we got here. And we rewrite it into two parts. And note that the second part is 0 after you do the integration. Because when you do the integration, you will find the antiderivative of this integral is sine 4x, which vanish at 0 and 4 pi. So here is our final answer. So here is problem 12. By a first look, we have the square root x inside the sine function and also at the denominator. So we start with the substitution method. Here we let u equals to pi multiplied square root x. Then we solve for x, which is u squared divided by pi square. And then we got dx. Plug in all these terms into this integral. We can convert it into this way. And note that after substitution, the upper limit is converted to 21 pi. And then we just simplify it. So the u cancel out and the pi square also cancel out. So we left with a simple integral respect to the sine u. Then we just integrate it and plug in numbers. And here the cosine 21 pi can be written as 20 pi plus pi. So it equals to cosine pi, which is negative 1. So the final answer is 4. Now we move to problem 13. So here we need to deal with the tangent square integral. Before solving this problem, recall that we are familiar with the integral for secant square x, which is tangent x. So we try to convert the tangent square into secant square. Use the trigonometry identity, we have 1 plus tangent square is secant square. So we apply the trick by adding 1 and subtracting 1. Now we have the secant square term. Then we split it into two terms. So we got the answer. So now is the problem 14. This is an interesting problem, and the key is to deal with the floor function here. First, let's see some examples for the floor function. The floor function 0.1 equal to 0, and 0.9 equal to 0, 1.7 equals to 1, and pi equal to 3. So we can split this integral in this way, and for each term we deal with this floor function. For example, for the first term, the x goes from 0 to 1, so it takes a value like 0 point something. Then after take the floor function, it became 0. Then for the second term, the x goes from 1 to 2, so it takes like 1 point something. After take the floor function, it became 1, so on and so forth. Now you may integrate them term by term. The first term is easy, and for other terms, by using the substitution, you will find that they can be converted into the integral, which is identical to the first term. But I prefer to write it into a compact form. And here we got this. Next, we use the u substitution, and let u equals to x minus n. So we got here. So this is integral respect to the u square. And the result is simple, which is just 1/3. so it became a summation over 1/3. And note that here n starts from 0, not 1. So it's totally 256 times 1/3. And here is our final answer. Now let's look at the problem 15. We have radical terms for x, so we use a substitution, and we got here. After put them back into this integral, we got this equation. Then we take the factor 4 out of the integral. So we are ready to do the integral by part, and we got here. Expand and simplify it. And we do the integral by part again. And simplify it. And integral by part one more time. So we reorganize and simplify it. And finally, we replace the u with the substitution. And here is our final answer. So this problem is not hard, but we need to be careful on the calculations. That's all for today. I will go through problem 16 to problem 20 in the next video. Thank you for watching. Please subscribe my channel if you like it.